internet time is somewhere between the two. Good morning, everybody, and welcome, if you haven't been in here for the first talk, to the VHF and Upstream. The fire exits are there and there. If the fire alarm sounds, please leave the building in an orderly fashion, go down the stairs and assemble outside in the car park. No recording of the lectures is allowed, both audio and visual. They are being recorded on the behalf of the RSGB, wave his hands in the corner, and will actually be available on the RSGB website and then eventually on YouTube. Please switch off all mobile phones or turn them to silent. And it says on my reminder, don't forget to purchase the Expedition Raffle Fund tickets. But as they don't do VHF on the ones that they do here, I shall refrain from that one. It gives me absolute pleasure to invite the first of our overseas guests to this theme, Bo Hansen, OZ2M, who will be talking about PI4, the digital mode, and beacons and why it's a success. As RSGB VHF manager, I get asked all sorts of questions about beacons and saying, what's this PI4 thing? Why can't it use JT65? Why can't it use FT8? Why do we have to have digital? What does it all mean? And how can I make sense of it? So I'm hoping
then I'll sort things out. I'll try.
Bo is going to explain it all for me. Bo Hansen, take it away.
Thank you very much. And good morning, everyone. When I make presentations, please stay awake. I expect at least one question per row, and there's a lot of rows occupied here, so please. And do it sort of during the presentation. It becomes much more interactive. Logistically, it may be a bit difficult because we'll put an effort on John.
I could run.
Otherwise, I will try to repeat the question if I understand it. I may not do it. Your call signs and names and so forth is not really that important for the recording, I guess, unless you want to sort of expose yourself. But that's a different story. Anyway, as John said, this is a PI4 presentation. And for those who never heard about it, I'll try to explain to you what it is and why. There is a reason behind it. Just like most things, and also the success. And some will definitely question if PI4 is a success or not. I'll show you some numbers, and we'll take it from there. But please challenge it, definitely. That's also part of the story. Then I'll wrap things up with what's next, and that's the synchronized beacon project. And hopefully many of you who are here have beacons. And I will try to persuade you at the very last minute to go home and change them afterwards. So we'll get back to that. Now, I'm pretty sure you're still awake. And this, if there's only one slide you can remember, this is the most important one to remember, right? Always put on the right footwear. Always. Your mommy probably told you that a long time ago, and warm clothes as well. But let's just stick to the footwear. There is a reason why you put on skates if you go on ice. They are very fit for the purpose. And you can go very fast, provided you're on ice. But if you wear skates hiking, you will most likely break a leg. And likewise, if you play football, they're very good on a football pitch. But if you take them to a ball, somebody will start laughing at you, right? But how about hiking boots? They are sturdy, they are a bit slow, but they can pretty much go anywhere. So sometimes it's a good idea to have sort of a general purpose footwear. Now, I have a phrase down here, and that's also very important to remember. I'm not sure everybody can see it at the back, but it says there are no free lunches when it comes to sensitivity, flexibility, robustness, and speed. These are definitely not fast shoes or footwear. But again, they're good. Skates are much faster, provided the right surface. So a very important message. Now, who are the beacon users? I showed this back in 2011. I'm pretty sure it hasn't changed much. I divide people into 3/4 groups. There are FM users who probably don't care much about beacons, right? Then there are sort of digital DXers, a relatively new phenomenon. They've been around for a decade, maybe a bit more, depending upon modes and so forth. But the good thing about the digital users is that they may become real DXers like us, right? But what I've seen in very many cases is that they don't really got a good understanding of propagation and what it really means and the implications and so forth. But over time, they may learn. But then we have class 2A, which are sort of the rest of us, or at least where we were. Some of us have moved into class 2B, that will use whatever it takes, digital, analog, and if there is another mode, could be light, whatever, but at least we'll take it from there. So over time, some of these in class 3 may get into class 2B, into sort of proper DXing. And I'm pretty sure that some of FM users that we've seen recently may have moved into especially the FT8 scene. There was a phrase on the ON4KST chat a couple of nights ago saying, "Wow, great, season is over, the FT8 tourists are gone." I'm not sure if the one who said it is present in the room. Anyway, sometimes you frown on these, and if you live in, say, touristed areas, during the off season, you really look forward to new tourists coming. But once they're there, you really like them to get, well, home again. Whether that will happen or not with sort of the FT8 scene, I don't know, but time will tell. But the OZ7 IGY history is why all this, why add digital modulation to a beacon? It has worked perfectly since 1957. I got the idea back in 2009, I believe it was, seeing some of the work been done over here by Andy G4JNT, and that sort of inspired us to say, what should we do? We probably like this as well. My first WSJ TQSO was in 2001, so I did have some history or track record even prior to 2009. But to make sure that we built beacons for the users, it's not just for the technical people who built the beacons. We made a survey, and I did lots of presentations, primarily in the Scandinavian countries, or at least in the area where OZ7 IGY is used by the users that we sort of classified before. But it's very interesting that there were more or less these kind of statements. Please don't change it. We want it just the way it is. I'm pretty sure the very same argument was said back in, I don't know, beginning of last century when AM saw the light of day. This has absolutely nothing to do with amateur radio. CW is the only thing. And that story probably goes on and on and on. But then somebody said, well, there should only be CW and carrier. Others said, no, only digital. Others said, no digital, CW only, even don't have a carrier on it. Somebody said more carrier, less carrier, and so forth. And you can sort of read through the entire list here. The message is everybody wanted something different. So what we did was to sort of conclude on the various statements made and said, okay, this will probably fit into a 1-minute sequence. It has to cover all 3 aspects. That is the digital modulation, the classic CW, and a carrier. And then there was a trade-off, how much should the digital part, the MGM, be? And the idea was it should be more sensitive than CW, because there's also a timing issue and so forth. I'll get back to this a bit later. But whether it's a digital beacon or not, there is a very interesting point here. More power, less power. Oh, how to solve that? There is no doubt that most beacons do not have the same ERP as a standard station, say 10 elements on 2 meter and 100 watts at least, or a kilowatt. It would be really nice if we could have beacons at that level. But then somebody has to pay the electricity bill, and that's an issue. For us at 7 IGY, we have 12 beacons up and running, and we use 800 watt continuously. That's an electricity bill of a bit more than £2,000 annually. So that has to be covered by somebody. We pay for everything there. But this was a very interesting way of doing things. So it ended up in designing this PI4, and it's sort of a subversion or derived from JT4, which many of you probably know that has been used in the WSJT suite for quite a while. It's very robust. It's a 4-tone modulation. It's wide-spaced. PI4 is not as wide-spaced as the most extreme JT4, at least the sort of native PI4 mode. And the reason for using 4 tones and using wide spacing is that we also had an ambition to make it decodable via Aurora. And we'll get back to that later on, the multipath issues and so forth. The sensitivity is between -22, 23 dB. That is sort of an extrapolation of the JT4 modulation. However, Klaus, DJ5HG, was involved in the design, and he said it's not sort of a direct translation because the synchronization vector, now it becomes rather technical, is slightly better than the one used in JT4. Whether that's true or not, I don't know. I just took the design from him, or the synchronization vector. Now, PI4 transmission lasts just about 24 seconds, and that gives us a couple of dB sort of improvement from the very best CW operators. However, I'll get back to that later on again. And there's a payload of 8 characters. The reason for having 8 characters is that sort of a standard call sign of 6 characters, and then you can have /B, because that's needed in some countries to be able to identify the beacons, because they are personal. And they have to do it. It's not just sort of a courtesy they do to other people. The regulator states that they have to do it. Now, we have a 60 seconds sequence, and there's another beauty in it. There's exactly 360 sort of digital symbol durations in a 1-minute loop. That makes averaging very, very easy compared. Now, I've seen very many statements in sort of these neck of the woods that carrier is king. And there's a lot more carrier in JT65 and JT4 sequences. A lot? How much is a lot? 1 second seems a lot to many people then, right? Because there is, as this one shows, about 1100 to 1300 milliseconds more carrier in the typical sequence used for JT4 and JT65. That's not really a lot, is it? So don't be lured by the numbers. And another thing which we'll get back to later on, it's PI4 does not really sort of exist in the AF domain. It's an RF specification. So the interrelationship between the tones, the carrier tone in the beacon context and so forth was defined initially. So there was no discussion afterwards, where is the tuning and so forth. And finally, the name comes from sort of an adaptation of lighthouse or beacon in Greek and Latin and so forth. So it's Pharis Ignis 4. It has nothing to do with pies or the number pi or whatever. Not at all, even though it may look like it. So the tone spacing design now becomes really interesting, but also quite technical. This is a way of illustrating it. At the very top of the page, you can see the thick lines here. That's sort of the nominal carrier frequency of the beacons. And in the sort of VHF, UHF range, and even to some extent in the microwave range, 1 kilohertz is still sort of the dominant beacon spacing. I'm pretty sure it will. Well, I think it will be extended in the microwave range, but at least from a VHF, UHF context, 1 kilohertz is the kind of thing that has to be taken into account. The FS space that you can see, that's a frequency shift if that's being used. So within this sort of spring green color, that's the area where the tones can be placed. And the white space tones here are illustrated. That's tone 0, 1, 2, and 3. And if we compare it to a narrow spacing system, like FT8 or WSPR, the tones are just as adjacent to each other. And that makes them very sensitive to path distortion. As you can see here, the bins here are supposed to illustrate the FFT or the digital sort of, what do you call it, chunks of the digital domain. So if the path distorts, then in the narrow domain, the tones over time shift to the next one or the adjacent bin. Of course, the decoder, to some extent, can handle this and try to track over time. But if this is a rapid change, for instance, on meteor scatter, that may be very difficult. And even though they sort of go in one direction, they can then go back again, like sort of a spiral over time. And that makes it very, very difficult for the decoder if the tones are just next to each other. That becomes a lot easier when the tones are wider spaced. So the next thing here to remember, that's the red message again. Sensitivity is really nonsense. A lot of people are lured by the numbers of, say, Whisper, which is minus 28 dB. Yes. And then we're back to the Footwear again. Whisper is like sort of a pair of skates. They are very, very good on ice. So if you have a smooth surface, smooth path, then they're perfect. Now, some people say that, yeah, but I've made decodings of Whisper on 10 gigahertz. So it works. It definitely does. And I'm pretty sure it also works on 134 gigahertz, but not as often as it could on 137 kilohertz. Because just getting one decode is not enough really to prove that you got a link. So in sort of professional communications, you talk about link probability. How often is for instance, a microwave link open, or even a fiber? It's 99.9999% or whatever it is. And that's what really matters if you have to use it. There's no problem in going into a casino and you throw your 4 WSPR dice and you have 4 sixes. It does happen, but it's not as often if you have another digital modulation. Another thing in this respect, that's the way the synchronization is distributed in the transmission. And I've listed sort of 4, 5, 6 different ones here, at least depicted in 4 different pictures. You have PI4 at the top, which has sort of very same way of having the synchronization in the transmission, similar to JT4 and Whisper. I was a bit lazy doing the top one. It's not so that the synchronization is at the very same time in both tone 1 and 3. It's more sort of, it's either 1 or 3. But the thing is, there is synchronization happening all over the transmission. And in JT4 and PI4, it's 49 to 50%. It's actually only 0.4% difference in the way the number of synchronization tones. In JT65, it's 50%. In JT9, it's down to 19, and in FT8, it's 27%, but made in a very different way, where you have sort of 3 synchronization blocks at the beginning, at the center, and then at the start. And this, of course, means that if you have this, this is very easy to imagine, that if somebody jams it here, here, and here, then FT8 will have a very, very hard time. It may be a little bit more difficult in JT9 or JT65 because it's more sort of evenly distributed. However, synchronization happens on only one frequency in both cases. This is actually the very long sync tail that you hear at the end of the JT65 transmission. It's very sort of distinct. But this shows that if you jam it, or if you not necessarily jam it, but if the path is distorted heavily, then finding the synchronization can be very, very difficult. Even though, again, the decoder can try to track it. Whereas the white-spaced ones, having the sort of 2 tones being used for it, makes it easier to find it. And there's a very interesting point in this. I don't know how many of you know JT10. It's not a protocol as such by Joe Taylor. It's the Russian guy who makes JTDX, who has invented JT10. It's actually a JT9, but instead of just having one tone, he has another synchronization up here as well, with frequency upwards here, and the tone number. So it has synchronization on tone 0 and tone 9. And again, to have sort of a more robust way of finding the synchronization pattern. So this is also part of why things become robust. Now, in a multipath context, again, down here, we have the FFT bins. And this is sort of a very typical pattern on VHF, where you may have, say, a carrier here, and then you can see there may be a plane coming into the path between you and the beacon or the signal, and then there's a second signal coming up here. It could also come out here and cross the direct path signal. Tracking that shouldn't be that difficult. But a clever decoder design has to take this into account. And to some extent, that can be handled. But the thing is that this one, the blue one, also has its sort of changes over time in amplitude. So there are many sort of parameters to take into account. And if we go into to a range scatter or on an aurora context, then it more looks like this. On 2 meter, this can be 400 hertz wide, so it takes up a lot of carrier or bins, which makes it very, very difficult to sort out where the real signal is. And sometimes you don't even have the direct path. Now, the way to do it is then sort of increase the bandwidth of the detector, and then try to see if there is some energy inside there. And of course, when you increase the bandwidth, you lose sensitivity. So that's a trade-off, but at least you can do it. So with JT 65 in comparison, which is used in a lot of beacons, we can compare it to PI4. What I show here might look a little bit confusing, but in the first picture here, you have JT 65, and you have tone 1, 2, and then 3, 4, 5, 6. It jumps one FFT bin for JT 65 mode. And then you out here, it's not proportional, so you can't scale it properly. But this is tone 65, located in bin number 130. Now, PI5 looks quite different, where we have tone 0 here in bin 0, and then out here in bin 40, we have tone 1. So there's a lot of room for sort of wobbling around. And the actual size of these ones are pretty much in the right size. So these two pictures to illustrate the challenges in a JT65 coder, where you have all these tones, or it could be in here, in the very same transmission. Another thing about this picture here is this is the sort of the length or duration of a PI4 symbol. And this is the very same length in the JT65 domain. So you even have sort of, for one symbol, it's there for a longer period of time, or has to be there for a longer period of time in the very same FFT bin, which means that it's also more sensitive to being sort of displaced into the adjacent bins. Again, all this matters when you want to choose which modulation to use. That was the digital story. But as I told you earlier on, there's also a human side to this. And when we decided to design PI4, we also had to take all the analog users into account. So we decided that we should have the very same tuning frequency for any part of the sequence. And preferably, it should be just like the way we've always done it. You don't have to go to 1500 hertz. You don't have to go to 1270 or 1 kilohertz or whatever. So we said, okay, let's place the tones in relationship to the carrier, which means that tone 0, I'll get back to all these ones a bit later, that tone 0 is actually below the nominal frequency of the beacon, and then the rest of the tone comes out here. And what's interesting about this is that over time, we all lose hearing. And the first picture shows, if you can't see it, it says hearing loss in dB here, and then you have the frequency here. So if you're 30 years old like me, you can 8 kilohertz. You have a loss of about 2 dB in sensitivity. Remember, we talked a lot about digital sensitivity, but what about the human sensitivity? We shouldn't just sell that off for a digital thing. So again, back to the 800 hertz. But in reality, most of us tune in to a beacon or a carrier around 600 to 700 hertz. And the reason is it sounds nicer, but we can also hear it better, especially with increasing age. Again, if we take 800 or 8 kilohertz, if we're 60, then we have a loss of additionally 40 dB or something like that. Yeah, I shouldn't talk up there though. But again, if somebody says, "Hey, I can hear the new digital modulation much better than the CW," this could be one of the reasons why. If you have to tune into the frequency or the digital part in, say, 1.5 kilohertz, and then you have the carrier perhaps, I don't know, 200 hertz below, or even at the 1500 kilohertz tone, then it's quite obvious why you can't hear it as good. Now, coming back to this one here, it looks like a mess, and to some extent it is. I think you guys have more or less sorted it out now. Again, PI4 and the traditional tuning here at around, or nominally at 800 hertz. If you move PI4 into a 1 kilohertz domain, the PI4 moves along with it because, again, it's defined in the RF domain. JT4G had a definition, or I believe it still has, around 800 hertz for tone 0. Then this one for JT4FC and JT65B, in this picture are located at the old frequencies, or the initial frequencies in the audio domain of 1270 hertz. And then they move all around, and you have to change tuning. Yeah, okay, yes. And you have to change tuning versus mode. And that's not really helping the humans in this respect. So sorting this out, kind of, we took that into account for PI4. Please.
JT, in the latest WSJTX,
it's free.
it's 1 kilohertz tone 0 for all modes.
Yeah. You can go down to
But you
500,
can
600, right?
You can actually tune any way you like, but the official frequency is
Yes.
1 kilohertz
Yeah.
now.
But I think you can go down to 500, is that correct? Or?
Something like that.
Yeah.
But the old 1270 hertz.
Yeah.
However,
But I'm pretty sure you know the issues about installed base.
But
That's always difficult to handle.
I would say there is a difference between what Joe Taylor publishes and what is wise for beacon planning, because as VHF manager and across IARU, we actually have to fit all of these beacons into
The structure, yeah.
and actually being able to fit it in and keep it in reasonable slots instead of spreading over 2 or 3 is quite important. So whatever might appear in WSJTX might need an offset tuning to fit good beacon planning.
It probably is, yeah, because it was a mess, and you had to sort of retune versus beacon, and they didn't use the same implementation, all of them either. So it was kind of tricky. So that's a very valid note. Now, again, this was the design. These are actual numbers. 27 of 54 digital beacons in Europe use PI4. Somebody surprised? Now, I had expected a question here, though. Yeah, that's easy, because IGY, you told us earlier, uses or has 12 beacons up and running. So that's half of 27, more or less. That's not the case. IGY counts as 1.
You've penetrated Germany as well now.
IGY, irrespectively of having 12 beacons on the air, only counts as 1 in this. this also means, though, that beacons like 3NGI also counts as one, even though it uses PI4 on 6 meter, JT65 on 2 and 70, and JT4 on 23. So it is not the full picture, but at least it gives you a good idea that I'd say that's a pretty good success. And if I'm not mistaken, I think the number will go up in both columns, to be honest. And of course, this is only in a European context. Globally, my gut feeling is that there are really not a lot of, say, digital beacons. There might be a lot of the people having whisper transmitters considering themselves as beacons. In this context, they are not considered a beacon. Sorry to the overseas audiences, but I think this is pretty good. I sent out a questionnaire, but this is the actual number, 27. I sent out a questionnaire to a lot of people, and I'll get back to that after this hardware presentation, or the hardware listing. But these are 19 different devices from 9 different people or groups that have implemented PI4 one way or the other. So 19 different hardware devices. It's not just sound cards. A rather interesting one, this D. Oras, a German. His father's a radio amateur, but he persuaded his son to do an implementation on a Raspberry Pi for a 23 centimeter ATV beacon. So it's a sort of multi-mode or double multi-mode beacon. But otherwise, there are very many different designs. The SR9 RMF is a recent design. I think they found an analog devices evaluation board of some strange sort. I haven't figured out what it is. I've not seen it before. But otherwise, there are, say, quite many. Tomorrow, I'll address the RF0, which is a new platform that may also be interesting to some people. Now, the questionnaires I sent them out to all the people I could identify email addresses on the UK microwave, UK beacon reflector, and other people that I sort of have in my address book. So to some extent, you could say that there are sort of people in this that are more beacon-driven than just regular users. I had a couple of emails back and forth with Robin from Beacon Spot, if you could help me out with email addresses, or even say just call signs, and then I could try to look them up afterwards on qrz.com. But that becomes very boring. But just to increase the pool size. But this shows that, well, many people were not active on HF, but some are active on HF to 24 gigahertz, and they use PI4 beacons, just like any other beacon. From time to time, somebody uses daily, somebody during openings. No big surprise in this. And the primary use, checking propagations, antennas, and so forth. And that's a very interesting one down here. Why? And why is it useful? Well, to have sort of a baseline of the conditions. And that's one of the very important things I think is interesting, because if you go into a site like WhisperNet, for instance, you can see the immediate conditions, but it's very difficult to see whether they are better than average or worse than average, and that's really where sort of the history comes into to play. That's just a database project in itself, more than sort of a radio project. Now, another feedback or other feedbacks are disadvantages, difficult to implement in old hardware. That's somewhat true, yes. Opera is definitely easier, which is listed down here, easier to implement. There are too many different modulations around. The thing about digital modulation is it's very easy to make it different. It just requires one bit. That's a bit more difficult in single sideband modulations. And dedicated software, well, WSJT is also dedicated software. But to some extent, that's true. The view on it, good mix of human modes and youth stuff and so forth. Too many sequences, too much digital in the sort of overall sequence. And one of the comments was, limit the number of digital transmissions in sort of a greater cycle down to about 1 to 4, and this number indicating CW and carrier. The feedback, at least initially, we got from Denmark and other places sort of around RGY was, no, there should be a sort of an even mix, and also to accommodate for people sort of catering for the digital part and not just the analog ones. So again, people could say, yes, don't change it. Others say, please change it. It's not an easy task to manage. Interesting point here. There was one here, actually, that I forgot to say. In this one, you could say, what about the remaining 27? They are more or less evenly shared between Opera, JT4, and JT65. So they share the remainder 27. Other feedback. This is very interesting. It's possible to decode these modes on CW before they are decoded. Maybe, yeah. But you have to be very good if you can do it. But there's a good thing about it. In CW, you can sort of jump in halfway into the sequence and get a meaning sort of out of it. That's a bit more, if not impossible, in the digital domain. You have to get the full package to some extent. And then a very interesting one. It's only young operators who implement it. We've sold a number of platforms, the Next Generation Beacon project. I also have a demo box here. My impression is not really that people are younger than I am, to be honest. So perhaps that's interesting. We'll get back to that later. And then some says, digital modes, they push the limit. Of course they do. It's something new. And all existing beacons should be converted. Again, there are all sorts of opinions about this. And that, again, maybe boils down to, we have to have sort of mixed mode beacons. We should not go fully digital. We should not stay fully analog. And that's probably true. Then there were some findings as well. You could rate the various statements from 1 to 5. What's interesting about this in sort of a common way is that there has a relatively high score, above 4, but again, up here there are some low ones. But these statements, yeah, both analog, digital, same sequence every minute, rather highly rated. Must not sound like a birdie. That was kind of to find out whether Whisper was a good idea for a beacon for analog users. And it can very easily be confused with a carrier. GPS locked, I understand that quite well. It's always interesting to have a beacon on frequency, but whether it should be sort of really frequency locked and so forth, maybe not. It's really not that important. Robustness, pretty good. Sensitive as well, and how easy? That's just a program. Now, those are the decoders. MSHV by LZ2HV has implemented PI4, and there's sort of our own decoder by Paul Eric, LZ1CKG, and you can download. There's a link to it afterwards. But we set out to decode Aurora, and we've done it. It was done by Jan, LA3EQ, 3 months after we went live with PI4 in spring 2013. These are the decoders. There are some different ways, again, to handle the multipath. The thing is, if you have a multipath, then there's also a time difference, and that can be sort of extended up to 1/10 of the symbol length. And the multi-search, that's a different way of sort of finding the decoding pattern or the synchronization vector across time in the domain. There's also an averaging and sort of multi-sequence decoder built into it that takes sort of cherry picks the best symbol versus time, and if there are no best, it just takes the average. So that can give you another couple of dBs in the sensitivity. Last 2 slides. Synchronized Beacon project. I'm not sure how many of you have heard about it. If you're more into 2 meter and up, you've probably not heard about it. If you're a 6 meter operator, you may have heard about it. But it's a global project. Well, originates out of Region 1. But the idea is to have beacon clusters sort of dispersed around the globe. It takes 150 of those for a full implementation, but it's probably possible, and it will make sense to make a reuse. And they decided to use PI4 and CW and carrier in this context. Now, I have an idea here, and it's sort of free for implementation. But wouldn't it be nice to have sort of a box on your or next to your radio with sort of a dedicated monitor, and you could use an embedded decoder, for instance, on a Raspberry Pi that has been done, and then a dongle, and you can set up a sort of a monitoring box that will give you an instant picture of the conditions on 6 meter. So that's possible. Now the final one is, should you use PI4? Well, it's back to the footwear thing. What type of footwear should you put on? Today, probably a pair of normal shoes will be fine. If you're going for a run, put on your sneakers. Really think hard about it. There are options out there. And again, should you only go for one particular type of mode, then PI4 will not be the thing, perhaps. But for a more general purpose perspective, yes. And again, who are the users? So it might be a good choice, a popular choice. At least you could say half of the beacons implemented already now uses it. And here comes the killer argument, right? You can be a young operator. You don't even have to go through plastic surgery. As one of the arguments or the questioner said, you will be, or you are, you're not just being it, you are a young operator. Best of all, right? Thank you.
Right. A question or two when I have to use the right shoes to get across the room. Any questions? One from Paul right at the back. Here you go, Paul.
Yes, Paul Nichols, G8AQA. I'm in the process of designing a 10 gig beacon, so this is obviously very relevant. I also find out when I'm on the hills trying to line up dishes that some beacons don't have a long enough period of CW to make it, with QSB, to make it easy to align direction, both vertical and horizontal. So I'd be against filling up too much of the time with these modes. Maybe they should be done on alternate minutes or something.
The thing is, if you use CWFSK, you have sort of a constant carrier, more or less. John did address the sort of the transition from one symbol to the next in his previous presentation, but most of it is sort of constant signal generated, at least.
There's always a problem with digital amateur modes of jitter and things that muck things up, such as multipath and delays, and it makes it very hard. Any other questions? Dreaded silence. Well, look, Bo, that was really absolutely splendid, because I know some of this history started about 7 or 8 years ago when I told you I can't receive OZ7IGY because JT65 doesn't decode. And it didn't decode over a 700-kilometer path under flat conditions on 2 meters because of troposcatter that we'll hear about tomorrow. But actually, Bo, you and the team, congratulations on finding a new pair of shoes that is more suited than some of the other digital modes. So please, again, thank you, Bo.
Thank you.
The next talk will be at, he says, desperately looking, in half an hour's, sorry. The next talk will be in quarter of an hour, and it will be Noel G4 GTZ.